The Wood Innovation Design Center is a really innovative new project put on by the province of British Columbia to showcase advanced wood products.
The entire process has over 20 contractors and there's 10 consultants involved. By the time the project's all done, there'll be about 250 people that have all been involved with the project.
It's involved teamwork from so many different players, from the province to industry, from the forest sector to the design community and the construction community. Without each of those players really coming together and collaborating in this, there's no way we would be building something anywhere near this innovative. We wanted a building that was really simple, where the beauty would come from the wood and the details.
One decision that we made at the very beginning of the concept development was that we were going to build what we call a dry structure. We had to treat the structure acoustically and from a fire point of view without the help of concrete. So the wood itself had to achieve the necessary rigidity, fire resistance, and acoustic resistance. WIDIC included a number of innovative elements, but we also integrated a whole lot of engineering knowledge and information that we'd been accumulating over the years.
The wood products are the building, really. We spent a lot of time thinking about how to make sure that the wood was not only the technical innovation, but the beauty of the wood was what showed through the most. To do that required a lot of invention and a lot of first-time things.
So the Wood Innovation Design Center had some unique challenges with meeting the building code. We had to comply with two sets of regulations, the BC Building Code and the site-specific regulation, and we had to get approval from two separate authorities having jurisdiction, the City of Prince George and province through the BC Building Safety and Standards Branch. We had to undertake a series of fire tests to demonstrate that the joints between the CLT panels would maintain the 1-hour fire separation required.
This is a pretty aggressive test. The oven's running at around about 1600 degrees Fahrenheit for a duration of 1 hour.
This project could not have happened had the province not recognized that we needed to work outside the boundaries of the traditional building code. Not outside the boundaries of safety, but outside of the really unimaginative kind of way that we've been tackling the future of green building. You couldn't be more positive about the future of wood products. We continue to improve the way we forest, improve our relationship with the environment, with forest ecosystems. We are already doing a very good job at that. We can always get better.
Forestry is a good thing, that we're actually regenerating, we're sustainable. We do a lot to enhance the environment and the forests around us.
In Quesnel, I believe we planted about 9 million trees. We're planting fairly high densities here to ensure that there's more resilience. Everything we do is directed towards continuing to have flourishing forests.
That's what I really appreciate about how silviculture is practiced in BC. We can take the wood out of the forest and we can take it to the mill and create jobs and create all kinds of forest products that go across Canada, North America, and internationally. But I know that our silviculture practices are solid and that, that fiber is going to get replaced and the ecosystems will remain intact.
This is a project about wood innovation. We could not build a building of this size had we not chosen these new engineered products. CLT, Glulam, LVL, they all give us the scale that allows these new projects to happen.
The Wood Innovation Design Center, we're really pushing the envelope of heavy timber construction. So we had to work extremely closely with the architect, the engineer, and the general contractor. The cooperation was exceptional. This building is not providing material on site and then building something. This building is being completely prefabricated and shipped to be installed. So to do that, we have to have that 3D model done of that building. The design has to be complete. Modeling's a critical part of this.
The CAD modeling allows us to achieve a high degree of accuracy.
You have the advantage of building the whole structure virtually on a computer first, with all the details down to the last screw.
In a project of this size, there's literally tens of thousands of individual elements,
which really enables us to find out any critical points and resolve any problems before they come to site.
Given that this is such an innovative project, there's a lot of new elements that have never been done before. So a lot of what we're doing, we have to be creative and come up with brand new solutions. A big component of this was bringing on the construction team during the design phase. And this not only helped the design team focus on the crucial elements in getting the wood into fabrication, but also to get the wood here on time.
Normal construction allows you to wing it on site and sort of figure it out as you go. This is a lot less forgiving for that. So you need to have a fully collaborated design where all of the people involved have looked at the potential conflict areas and made sure that everything's going to go together smoothly. If you do that, the benefits are huge, both in the quality of the building and the cost of the building.
Wood is a lot more capable as a construction material than the industry gives it credit for right now, and we're really seeing that and proving it with this building.
I think it's especially great that the Wood Innovation Design Center serves as an educational facility with the UNBC as one of the main tenants, because that's how we're going to get new thinkers and new leaders actually learning about wood and its technology.
The Wood Innovation Design Center is very important to UNBC. It's a great opportunity for UNBC to develop a set of programs which allow us to expand our engineering role here in the north, but also bring new and innovative ideas into the construction of wood buildings. We'll also have the opportunity to look at BC Wood products and take those products, have them studied and used in this program, and then those students will be able to take them out with them when they go out into industry.
It's pretty profound to be involved in a project that really does complete the story, that begins right here in the forest with the seedling that's growing, the tree planters that are helping that happen, the ability for that tree to grow over its life to being something so magnificent in the forest, and then give a life well after that, and create a project that ultimately will be used by students that each and every day will enjoy it and will be studying and learning about what they can do with wood products. It's an amazing full life circle.
Right now there's a lot of attention being made to wood in design and construction. It's not just with the speed of construction or the cost, but also the environmental benefits of using wood.
I think as we continue to develop knowledge, as people learn to work with the material more and more, we're going to see the construction of solid wood buildings become more and more efficient and economical.
One of the great privileges is to be part of a project where there's been enough vision at provincial level to acknowledge that new ideas like this really do exist outside of conventional building codes. We're unique in BC that we've got a government that chose to support this building in that way, to allow us to try these new ideas. You know, we want to be a world leader in all kinds of industries. Construction, design, forestry, we are world leaders because of projects just like this one.